Alright, so we're going to look at 7.3, logarithmic functions and their graphs. I'm just going to go through this whole packet here and do each one of these problems and try to give you a little overview of what we're doing. So number one, it says that we're supposed to evaluate the logarithmic expression without the use of a calculator. Okay, so without a calculator, you're supposed to do this. Now your calculator will do these if it's just a plain old log. Well, if it's a plain old log here, first things first, that's the same as saying log base 10 of 10,000. I'll put a comma in there just to make sure I know how many zeros I got. That is read log base of 10. I'm sorry, log base 10 of 10,000. That's the way that's read, said. But if there's nothing there, you assume it's a 10. Now, a logarithm is just a fancy way of saying this to what power gives you that. This, let me write a good 10 there so you can see it. 10 to some power equals 10,000. That's what a logarithm basically does. So do you know what power that you'd raise 10 to get 10,000? And if you don't, you can use your calculator, start doing 10 cubed, 10 to the 4th, 10 to the 5th, whatever. But let's see, 1, 2, 3, 4. There's 4 zeros there, so it would be 10 to the 4th. All right, now in the previous sections, what we did, so 4 is our answer. But what we did before is we would rewrite this as 10 to the 4th, and when you had the same base, 4 is that value right there. Okay, so that's basically what we're talking about doing here is logarithms. 10 to some power gives me 10,000. Now some of them actually have numbers to them. Look at number 2 here. It says log base 8 of 64. Log base 8 of 64. 8 to some power equals 64. You gotta ask yourself, well, what? 8 something is equal to 64. Now, the last section, instead of me doing a question mark, I'll use an X. The last section, 7.1, we just rewrote the 64 as 8 squared. And once you have the same basis, you set your exponents equal. Right? But I think most people know that 8 squared is 64. So a logarithm is this to what power gives me that. Okay. I like to look at it I like to put myself a little X there, okay, and I draw myself a little bitty kind of circular arrows. 8 to that power equals 64. And I just think I like looking at that picture. I can picture this. I can remember a picture in my head a little bit easier. But I have to put the X there by myself there. Okay, next one. Log base 11 of 1. 11 to some power is equal to 1. Now, that might be tricky. Okay, well, how in the world do you get 1? Recall, we talked about before, anything to the 0 power is 1. Anything to the 0 power is 1. So what does this have to be then? It's got to be 0. Right? This guy is equal to 0. Your answer is 0. So there's a property in this then. A logarithm to any base, I'm going to use A for any base, of 1 will always equal 0. That's a property. You can take that to the bank. Okay. Log of any power, any base, sorry for the confusion, log to any base of 1 is always going to be 0. Oh, this is fun. So much fun. Next one. Number 4. Rinse and repeat. Log base 1/4 of 64. 1/4 to some power. 1/4 to some power is equal to 64. I'm just rewriting it. This is called a logarithmic equation or expression. This is an exponential equation. Logarithmic, exponential, exponential, logarithmic. We'll talk about that here in a second. So I've got it rewritten without the log in exponential form. We talked about this earlier. How do you get this to have the same base? Well, that needs to be, I like to do that as a negative, 4 to the negative power. Right, that gets rid of my fraction. That flips the fraction around like that. We don't write the 1 there. Okay. So that makes it 4 to the negative x equals 64. And we could write 64 as 4 to the third. Well, you got the same base now, so they cancel. And it's negative x equals 3. I just like thinking those things just cancel. That's just the way I look at it. If it's a negative x equals 3, then the positive x equals negative 3. Right, you divide both sides by negative 1, you get negative 3. So your answer here is negative 3. Right? Log 1/4. Log base 1/4 of 64 is negative 3. Negative 3. Now, there is a change of base formula here. You can actually check your work using what's called a change of base formula. And it's log. If you take the log of any base and any number here, log with any base of any number, okay, you can do that in your calculator by saying log b divided by log a. Just a plain old logs in your calculator. Any calculator that does logs can do this question over here. So, let's see if I can find my calculator. Nothing better in a video than a big long pause. All right. So I can take, like for this question, to get negative 3, I can do the same thing of log 64 over log 1/4. And we can do that. We'll just take the log 64. Well, log 64 over log 1/4. I get negative 3. So much fun. Called a change of base formula. Change of base formula. All right, what number are we to now? Number 5. Now you've got a logarithmic equation. So we got a logarithmic equation now. And let's try to rewrite this without the log. Exponential form is what we're trying to rewrite this as. We can solve this. Remember, it's this guy to that power equals that. This guy to this power equals that. Well, that's not too bad. 128 to the 4/7. 128 to the 4/7 power. I get 16. It's just that easy. I swear. Just that easy. Let me throw you off. Let's try another one. Let's put the log up in there in the power. Ha ha ha. You're thinking, well, I don't know how to do that. Well, actually, you do know how to do this. If you've done 7.1 already, remember how you do this where, imagine that's just an x. You want to get the same basis, 4 and 16. 4 squared is 16. So you could rewrite the 16 as 4 squared. Well, you got the same basis. So remember how I just like to say they cancel? Log base 3 of x is equal to 2. Remember what you do to rewrite this? 3 to that power equals that. And 3 squared, I don't need the calculator for that. 9. 3 squared is 9. So your x value, way up there, is 9. Man, we're trucking right along here. Number 7, log base 4 7x equals 2. I'm just going to rewrite it from logarithmic form to exponential form. I'll rewrite it without the exponents, or without the logarithms. 4 squared is equal to 7x. That doesn't look as bad as what I've covered up here, does it? But it's the same thing. It means the same thing. So divide both sides by 7. Might as well just go ahead and square that, right? 16 over 7. tough stuff. Well, there's another type of logarithm, and it's called the natural log. There's another type of logarithm. It's called the natural log, and it deals with e. Remember we talked about e being this nice number that's irrational. It's sort of like pi. It's 2.7182 whatever, 7183, I guess, if you rounded it. So here's what natural log is. The natural log is the same thing as log base e. That's what ln is. Okay, so this is the same thing as this. I'm just going to rewrite it. It's rewritten. Log base e of e to the x equals 9.6. Okay, now if I rewrote this, remember what it would be? This to that power equals this. This guy to this power equals this. E to the 9.6 equals e to the x. Well, that's stupid. They got the same basis. So if they got the same basis, 9.6 equals x. I mean, that's always going to happen, right? That would always happen. It's e to the 9.6, and you got an e inside here. So check this out. If you ever see a natural log next to an e, they pretty much kill each other off, and you're going to be left with whatever the power is up here. It will always equal a. It'll equal what that power is. ln will always kill off the e, that nature, and you'll be left with whatever the power is. Because you'd rewrite it like this. You'd say e to some power gives me e to that power, and that power is just that power. I know it's confusing, but you can rewind it and let's do it again. So if you see ln and e's together, they kill each other off. Just like now, it has to look like this. It has to look just like this for that to work. All right. So let's look at another one. ln 6x plus 10. Remember what ln is? It's exactly the same as log base e. I want to write this ln as log base e. Maybe it makes a little more sense here. 6x plus 10 equals 4. Well, remember how I would rewrite this. E to the 4th power equals this. E to the 4th power equals 6x plus 10. Right? E to that power equals this. Well, now e to the 4th is a number. E to the 4th is a number. Let's see if I can find my calculator here. Oh, here's my e. Second. No, it's right here. E. Your calculator might be a TI. I think it's second ln. And it's e to the 4th power. That's a number. It's 54.59. I'll just round. Well, let's not round. Let's see. If I solve for x here, the first thing I do is subtract 10. Okay, so we'll subtract 10. So take that number minus 10. 44 point all that stuff. Okay. Then once I did that, I'd be left with 6x. And how do you get x by itself with a 6 in front of it? Divide by 6. So divide everything by 6. So I'm going to come over here to my calculator. Divide by 6. 7.433. 7.43. The question only says around the nearest 2 decimal places. So 7.43. Alright, 7.43. Now here's what I've seen some people do this before. Instead of them rewriting this as log base e, they'll rewrite this. What they'll do is they'll come over here and say, well, I'm going to kill off the e. I'm going to raise both of these to the power of e as a power of e. So e to the ln 6x plus 10, e to the 4th. And essentially it does the same thing. E to the ln power kills the ln's off, and you're left with this guy. So if that were true, you'd have 6x plus 10 equals e to the 4th. It's the same difference. It's the same difference. It's just a little property as if you have this raised log the same base, it kills each other off. And we'll talk more about that in the next chapter, those properties. But you can always change it to log base e's, do a little conversion. Life is good. Life is good. Okay, question 10 says, write the following equation in logarithmic terms. Write the following equation in logarithmic terms. So we're talking about the top one here. Write this guy in logarithmic terms. So we're basically doing the same thing we did, just in reverse. So what's the base here? Remember, vocabulary says this is the base. And remember how I've been saying this. Log, base, and then that little number of, so which one do you think this would be? This guy equals the power 4. Remember how that works? This guy to this power equals this, right? This guy to this power equals this. So that's what you're doing, log base 1.8 of g equals 4. That's all you do. You don't do anything other simplifying. You just put them in the computer, and you'll be done with that question. All right, same type question, but it's a little bit different. Write the following logarithmic equation as an exponential equation. Rewrite this without the log. This guy to that power equals this. 1.8 to that power equals this. That's it. It says you don't have to simplify anything. It just says do not simplify your answers. So that's it. That's all you write. That's logarithms.